Hey everyone, how's it going? Today we are going to be doing another LeetCode 75 study plan series problem, and we are still in our HashMap slash set category. We're actually in the last problem. This problem is called equal row and column pairs, and it's ranked medium. We've seen it in Adobe, Apple, and Amazon. Alright, so for the instructions. Given a zero-indexed n times n integer matrix grid, return the number of pairs R and C such that R at ith index and column C at jth index are equal. A row and column pair is considered equal if they contain the same elements in the same order. Okay, so um, if you don't understand what the problem statement is just directly after reading it, we'll look over some of the examples, right? Um, in this particular problem, we're going to output 1 because there's an equal row and column pair at row 2 and column 1. And remember that this is zero indexed. So row 2 is going to be this one right here, 0, 1, 2. Rows going this way, columns going this way. So 2, 7, 7, and then column 1, 2, 7, 7. So that's one pair, so that's why we returned 1. So I hope that you guys get it now, and we can go ahead and dive into the code implementation for this. So the first thing that we're going to want to do is establish an integer that keeps basically record of the number of, or we can just call it count, right? And it's going to keep a record of the number of pairs that we have for the column and the rows that match. So we'll be using this later on. And for now, we're just going to put it at 0. Okay. And then we're going to have, so basically what we need to do, right, is we need to use a hash map. That's the category for this problem, right? And so the idea is that we're going to have one hash map for the rows and one hash map for the columns. And then at the end, we're going to go through and we're going to check the rows against the columns and see if they add up, and then we'll add them. If they match, we'll add 1 to the count, and then we return that number. So the first thing that we're going to want to do, since we're going to be using for loops to populate the hash maps, we're going to want to declare our number n, which is going to equal the grid length, which is the length of the input array, right? And the reason that we're doing that is to just in terms of simplicity. Now what we're going to want to do is create the hash map, right? So it's going to be a string and an integer, okay? Because we're going to record the key value as a string. That way it's easy to compare it, all right? And then we'll use an integer for our value, and then that's going to match the frequency, right? So the string is going to represent the combination, so either the row or the column. In this case, it's going to be the row. So it'll be for row 321 as a string, right? It's going to be frequency 0, right? Because there's, in this example 1 right here, there's just one row that's 321. So we're going to call this row counter equals new hash map, right? And this is just how we initialize it. Okay, and then now we want to do the for loop. So we'll do a for each loop. So for each integer array row in the grid, we're going to create a string called row string, and then we're going to use arrays toString row. All right. So basically, what this is doing is it's getting the entire integer array row in each iteration of the grid. So it's getting each row and it's turning it to a string, and it's storing it in a variable called row string. And we use that with the built-in library arrays and the toString method, using row as a parameter. Okay. So then now what we want to do is put this inside of the row counter hash map. So row counter dot put, and then remember we're using a string is our key, so it's going to be row string. And then we did this in our last video. What we're going to use again is the get or default built-in method for hash tables or for hash maps, which basically means that if it exists, then we're going to add 1. And then if it doesn't exist, then it's just going to populate with a default value. So in order to do that, we're just going to do row counter dot get or default. And then what we're going to put in for our parameter is the default value, which is just going to be row string 0. And then if it already does exist, then we just want to add 1. Okay? So now what we're going to do is the same thing except for the columns. So for int c equals 0, c is less than n, c++. Alright, and then we're going to set up an integer called call array, or an integer array called call array. And then this is going to be the length of the grid. So in order to, because arrays unlike lists aren't a fixed size, they're aren't dynamic. My bad. They're not dynamically allocated, so we have to set it to its size when we're initializing it. So we're going to set that to n. Okay, and then for int r equals 0, r is less than n, so we're setting up a nested loop right here. r++. Okay, so call array at index r equals grid r c. Okay, and then now what we want to do is we want to check our rows against our columns. So in order to do that, we just want to use the get or default again, and I'll show you how we're going to do this. So row counter dot get or default arrays to string call array 0. Alright, and then now all we have to do is return the count. Alright, let's go ahead and run this. Awesome, so there you have it. Passes the first 2 test cases. Let's go ahead and submit this. Alright, yes, so we have our solution that passes all the test case. And then for the time and space complexity, let's go over that real quick. So for the time complexity, it's going to be big O of n to the second power. And the reason that it's n squared is because we have a nested for loop right here. Normally, if we were to use a brute force solution that wouldn't include a hash map, it would be a big O of n to the third power, which would be obviously a lot slower of a solution. So this is actually an optimized solution that we can use that would be acceptable in an employer interview. So these type of grid problems are definitely something that pop up, so it's good to know how to navigate these problems. So for the space complexity, it's actually going to be big O of n squared, because we can, so we have our input array grid, right? And so for the row counter, the row counter can have n rows of length n, so therefore it has a space complexity of big O of n squared. And yeah, so that's it for today. I hope that you guys thought that this tutorial was helpful, and we're going to be moving on to the stack category next video. So please leave a like if you found this video to be helpful, and subscribe for more related content. And as always, please feel free to leave any comments with suggestions or feedback, and I'll look forward to seeing you in the next video. Bye.